just real quick. All right. So basically, I want to look right here. This is Chloe's. She's my daughter, in case you don't know. So I'm not really that concerned with you seeing this on her. Okay. So if you look, for example, right here, right, where it was the 1-8 practice, and I'm in her grade book. This also you could see through the modules. But what I want you to see here is that Chloe has uploaded a file, if it's going to show it. Yeah, it is. It looks like this. Okay. The way Chloe did this is that she actually printed out the paper. Okay. Then she wrote on the paper, right? Then she took my phone because she doesn't have a phone. Okay. She scanned it. All right. Then she emailed it to her school email, and then she downloads and then uploads it. The whole thing takes less than a minute. Okay. And so if you haven't figured out how to do something like that yet, you need to. Okay. There are several different ways people do it, but there's got to be some way that you are going to turn your work papers in. So every time it says turn in something, that means there's got to be a work paper that you actually turn in. Okay. So you're not going to do well in online math, just to be clear, if you do not turn in work paper where you actually wrote it out. Okay. That's just how it goes. All right. I would say two-thirds of people have figured that out at this point, and a third haven't. And so just keep reminding you of that. All right. All right. Now, here's the link again to the Nearpod for today. That's the last thing I got to do for in catching up on my grading is I need to put in the Nearpods for Monday. I'll do that right after class. Okay. So today I'm hoping you feel like this is Adam Sandler, right? That moment when you understand something in math class. I'm the smartest man alive, right? So today we're going to work on checking for if equations are true and writing equations for word problems. So the reason I went ahead and put in the Legends of Learning / liftoff for yesterday was because the way it lined up for me, I had 3 days of practice that were going to come from this lesson and only the 1 day from Monday's lesson. Okay, that's how I had it organized. Remember, I do send out weekly grade updates on Mondays. I list some of the bigger assignments that are missing, but all work is required, and each thing I assign has points attached to it. If you need help with some skills, target times Monday to Thursday, 12 to 12:45. All right. And then also like if you're newer and you need help with figuring out how to turn things in, we could do that also. I also put comments on your work. Sometimes it's just like good or excellent, but then if you miss stuff, I put comments on there that show you what you need to do to fix it. Um, and then, the other thing I would want to tell you here, if you're newer, is this. The way I have the course designed is that I actually go over every problem that I assign for practice. Okay. So if you look at like today here, you are in live lesson, so that's good. All right. Now, when I'm done, I will post the live lesson recording here in case you need to go back and watch it. Then there's the Nearpod that you're going to be doing while we're working. All right. Then there's the practice for today that's right here. Okay. So you'll click on that, you'll download it, you print it, whatever, or write on your paper. That's cool too. Then underneath there, you're going to click turn in 214 practice here. Okay. And then when you do that, you'll click, basically, there'll be a thing on there where you click start assignment, then you'll upload the file, then you'll turn in. Okay. Um, and then after that, on every day's module, there is a video. So what I would encourage you to do is you attempt the daily practice. Okay. Then you pull up my video here and you watch the video to check your work, fix your work, then turn it in. Okay. It's the same idea as if we were in the regular traditional public school. You do a work for homework. The next day you go in and you go over it in class. Hopefully you've had that experience. This allows you to do that. And then if you still have questions, then that's where you can go to Target Time and ask, okay, I'm still confused on this. All right, that's the best way to use this course design, and I think it's worked very well for the people who've done it. And I feel very good about that it's designed well so you can succeed. Okay. Um, so any questions about course design and what you're expected to do? And there's a weekly checklist that I would encourage you to print off and check off when you've done things. Okay. All right. Now, so let's see, last week, that's what we had. Again, make sure if you're not brand new this week that you've taken the Unit 4 test on progress learning. The end of Q3 is actually under 3 weeks away. So you need to make sure you're caught up, especially as we're going into a new unit now. And then I decided to modify how I'm doing entering points for Liftoff or Legends of Learning because it's getting really confusing for me to keep track of. So what I'm going to start doing is I'm going to start doing every day when I see somebody who's done the work, um, like the usage for the day, and I'll go put the points on there. So if you don't see points beside your name for the week on Liftoff Legends of Learning, that means I haven't observed you doing any this week. So if you have questions on that, you let me know. Okay. All right. So here we go. We're doing Nearpod today. Here's the code. I also posted it in the chat if you want the link. All right. And then I'll post it one more time and I'm gonna switch over. All right. Okay. So I got 13 of you in. There should be 25. That means we have 52%. 13 out of 25 is times 4. That's 52. So again, look, you fool no one by being logged into live lesson and not doing the work, because I basically am taking whether or not you're here or not based on if you do the Nearpod. That's how I think about it. Okay. Um, all right. So, and by the way, another thing that is I think an important skill to figure out for most of you is going to be how to split your screen so you have multiple things going on. Um, and I don't think mine's wanting to do that the way I have it right here, but there's a way that you can split your screen. I can show you how to do that if you need me to show you. You can come to Target Time. I'll show you how to do that. That way you can have you want your Nearpod pulled up and the Zoom. All right, so here we go. Get moving here. I know that took a while, but all right. So today we're working on both figuring out if an equation is true, what makes it true, and writing the equations from real world and mathematical situations. Okay. All right. So that's kind of the part we're on right now. All right. So I can match equations to real life situations they could represent and replace a variable in an equation with a number that makes the equation true and know that this number is called a solution to the equation. Okay. So, all right. So here's just a few things here. All right. One, expressions on either side of the equal sign must be equivalent to each other for the equation to be true. Otherwise, it is false. Okay. And so if you have the two expressions and it says equal and they're not equal, then instead it shouldn't be an equal sign. It should be an inequality where we use the greater and less than. Okay. And we've done some of this already this year. We're just kind of going over some of the technicalities of the terms. Okay. So anytime on these slides that I have something for you to write on, I'm expecting you to write on it unless I say otherwise, okay? So this first one here, so we got an equation. It says A plus B equals C. That could be true or false. Okay, so if A is 3, B is 4, and C is 5, is the equation true or false? So what you want to do on this is you want to say, okay, I want to substitute these in. So 3 to do what I'm doing here. Okay, if I have a draw on, that means you do what I'm doing. So 3 plus 4 equals 5. Well, no, that's not true. Is the equation true or false? Well, it's false. Here's how I want you to prove this. It's kind of hard to see right here. But if I go, so it's 3 plus 4 equals 5. Okay, so what I want you to do to prove that it is not true is that you just consider this side an expression and the other side an expression. 3 plus 4 equals 7. Okay, 7 does not equal 5. So what you'll do right here is you'll mark through that and say that means does not equal. Okay. So the way you'll prove it is like this. Okay. And so on the practice on Friday, I have some where you're supposed to prove whether it's true or not. That's how you prove it. Is yeah, Mary. Yes. All right. So that's how you prove that it is true or false. Okay. So new values for A, B, or C and C that make the equation true. Okay. So what you need to do right here is let's find some that make A plus B equals C a true statement. Okay. So you can pick some if you want to. All right. So I'm going to put A equals this, B equals this, and C equals this. All right. So go ahead and write on yours what are some that would make the equation true. So you try to make it true first. All right. So let's see here. I'm going to come up with, so somebody right here has got A is 3, B is 2, C is 5. Makes it true. Yeah, absolutely. Okay. So just something real simple. This is not supposed to be difficult here, right? So, for example, I could just leave A and B as 3 and 4, and then I'm just going to change C to 7. Yay, now it's true. Woo. And then A plus B equals C, things that'll make it false. I don't know, 5 plus 8. And then I'm going to say C is 4. Okay, that's false. Duh, right? Okay. Very simple. Okay. Again, X times Y equals Z could be true or false. Okay. If X is 3, Y is 4, and Z is 12, is the equation true or false? Well, 3 times 4 equals 12. That's a true statement because 12, when you do it on this side, 12 does equal 12. Okay. So new values of X, Y, and Z that make it true, and new values of X, Y, and Z that make it false. So go ahead and put those in. Okay. So put new ones in that make it true and that make it false. Okay. So yeah, right here we put 2 times 6 for 2. And so if X is 2 and Y is 6 and Z is 12, that's true. If X is 2 and Y is 2 and Z is 12, that is false. Okay. So just something like that. Okay. So I'll just put one in here. So for mine, I'm going to say X is 3, Y is 5, and Z is 15. Okay, that's true. All right, then I'm going to say 6 times 8 equals 2. Yeah, that's false, right? So that's not, okay, so that would make that one false. Okay, so it's not super hard. Just make yours look like that, or, like this one right here, right? Right. So you just need to put in values that would make it true or false, right? So like this, okay? Okay. So again, if you are not understanding what in the world we're doing here, what I'm saying is I go through and I put 10 points in the grade book every day that we do these, or if you basically did these while I'm doing them. Okay. All right, give you about 10 more seconds to get caught up. All right. All right, a couple people came back in. I'll post in the chat the Nearpod link for them if they aren't in yet. All right, so I'm gonna go to the next slide here. All right. All right. So we need to make sure we understand these things, okay? What does it mean when an equation contains a letter, like a variable? What makes an equation true? What makes it false? And how can we determine whether an equation is true or false? Okay, just be kind of clear on this, okay? So a variable is a letter that represents a number. We talked about that last unit. And there can be different values for the variable, okay? So for example, in the expression 10 minus x, the variable is x. If the value of x is 3, then 10 minus 3 equals 7. If the value of x was 6, then it'd be 4 because 10 minus 6 is 4. Okay, so that's just variable. Vary means change. So it could change. The numbers that don't have variables are called constants. Okay. Hey, reminder, if something happens to one of your slides, then you can go back and do the student pace one for that particular slide later, and just let me know to check both of them. Okay, so if somebody did that the other day and I remember, I need to check it. All right, so what makes an equation true is this, right? That if you have the number that's substituted in for the variable makes the equation have the same value on both sides. So for example, if you have m plus 1 equals 8, then 7 is the only solution because 7 plus 1 is 8. So you could not put 9 in for m and it be true because 9 plus 1 does not equal 8. Okay. If this seems super obvious, it is. It's just you're needing to understand the terms and what they mean. And if you noticed on the standards I was showing you earlier, that's literally one of our standards, okay? So another way that it might say it is like this. The question might say, is such and such number a solution to a certain equation? So the way that might be worded is like this. Is x equals 5 a solution to 4x plus 3 equals 19? So what you would do is you would say, all right, we're going to fill in 5 for x here, right? Substitution we were doing last unit. And then we're going to solve the left side here, the expression. So 4 times 5 is 20 plus 3. Okay, I want you to notice what I'm doing here. Because as much as you're like, dude, I don't want I don't want to have to do that. Too bad. I'm telling you this is how you have to do it. Okay. So then 23 equals 19. That is false. So we're going to put does not equal. Okay. So you cannot just say, no, it's not. Okay. You're not going to get credit for that. You substitute the value in until you get the same on both sides. All right. Or if it's different on both sides, you see how I got it down to one number on each side. So what I'm saying is you simplify the expression on either side to prove if it is true or false. If it is true, it should equal. If it is false, you can put the little slash through the equal sign. That means do not equal or does not equal. Okay. Questions on that? Okay. Oh, I got to erase this because that doesn't work that way. All right. So you need to prove these two. Okay. So just like I did on the last one, you're going to take 3, fill it in for the x, and you're going to prove it all the way down until you get something either equals 10 or does not equal 10. And the same for the 5 on the second one. Okay. So I want you to get started on that, and then we'll go over it in about a minute. Okay. So you should be working on this. Should see you starting doodling. So I don't even need you to put the word yes or no, honestly. You prove it's yes or no. I don't care to see the word yes or no. Okay. Okay. So some of y'all are not doing what I'm asking you to. You need to be doing it like this, not any other way. Okay. I'm telling you, this is the way you do this. Okay. So you put 4, you substitute in 3 for x, just like this. You need to do it just like this. Okay. Then you simplify this side. So you're going to go, okay, 4 times 3 is 12. You, look, even if you got to just follow me right now, that's fine. But I need you to see this is how it's got to look. Okay. This is how we do mathematical proofs. All right. So we're proving that that is a true statement, that that is a solution. Okay. So now you could write true. All right. You don't write it's true or false till you've done this. All right. Right down to here. We did those steps. All those steps are required. That's not like an optional thing. Okay. So you need to get it down to where it says 10. See, some of y'all are still skipping the last step. It needs to say 10 equals 10 at the end. Okay. So look at mine. So I have the substitution step. I did the multiplication step of order operations, and I did the subtraction. So basically, what I want you to see is over here, this expression was already done. So we're getting basically doing this expression to see if it's the same or not. Okay. All right. Now we're going to see. So this one's going to be a no. I'm showing you what a no one looks like. Okay. So is 5 a solution of 6x plus 2 equals 50? Okay. So we got 6. We fill in the 5. That means 6 times 5, right? Plus 2 equals 50. So we know that it's going to come down here. This makes it easier for you to see what I'm saying. The 50 is going to be over here the whole time. Okay. So 6 times 5 is 30 plus 2 is 32. 32 does not equal 50. So that is false. Okay. So that is what I'm wanting here. Okay. If you're like, dude, that's way easy. Why are you making me do that way? Because it won't always be that easy. So I'm showing you how to do it. Okay. You're learning how to ride a bike with training wheels first. Okay. Is what we're doing. All right. So everybody got it that way. Like, again, I frankly don't care if you don't want to do it that way. You've got to show me the proof. All right. Any questions? Give you about 10 more seconds here. Okay. This is actually the longer part of the lesson was this part. The other part is we're going to be working on writing out the word problems. Okay. And I'm breaking this unit into chunks because like different parts instead of throwing a lot at you at one time. So if you're like, well, why are we not starting with how to solve the equation? Because I wanted to make sure you understand the equations, what they are, and so forth. Then I'll come back and we'll work on the correct way of showing the steps to solve it. All right. So all of this is really important little building blocks. All right. So I'm going to go to the next one. Will you finish that? Okay. So now we're going to work on the other standard I'm working on today. So remember today I had basically 3 days of practice to go with this. So that's why it seems like I'm just jumping to a whole nother lesson. I really am. Okay. That's part of us having, two days of live lessons is I have to kind of get you prepared to work on several different things. All right. What are the key words? All right. This chart, you've seen something like this before, I'm sure. So the difference between when we were doing this with just expressions is the equal sign. So a lot of times it's like, 4 or less than a number is this, or, it's the ones that tell you, okay, it's going to be equal to such and such. Okay. So is, are, was, were, will be, gives, yields, results in, sold for. So there's various ways that you can look for is saying that it's the equal sign. Okay. So we'll practice some of those. So today we're going to do it for practice with the mathematical ones, like the 4 or less than a number. Then tomorrow's is going to be like the real world word problem type. Okay. Which are going to be both of those are things you're going to run across a ton the next few years. All right. All right. So here's an example. All right. So just you follow me on this one, you write it down. 5 less than a number is 20. Okay. So what I want you to see here is I think it helps to go through, find your keywords and what they are. So there's my equal sign, right? Is 20. Ta-da. I've already got the is 20 part. Okay. Now, 5 less than a number. So we can call our number X, we can call it Z, we can call it N, whatever. So let's say N. 5 less than means we have to flip the order. So that means a number, and then less than means minus. A number minus 5 equals 20. Okay. All right, here we got is again. So that is the equal sign, equals 48. All right. Then 4 times the number. So 4 times the number. So that's times X or N. Or you could just write 4N equals 48. Okay, make sure you got that written down. Then I'm going to get you to do a couple before I go over. Okay, so make sure you have those written down. Again, yes, I went over it, but yes, I also know that you're following along with me if you have it written down. Right? That's a part of us doing online math. It's like I'm not sitting in your house right now. So how I know you're following is that you're copying down the notes, right? And that's basically what we got here. All right. That's how I know you're not just sleeping through class, basically. Right. All right. Any questions on those two? Okay. I'm moving on in 5, 4, 3, 2, 1. Okay. Next one. All right. So I want you to do this. Okay. Um, so I want you to notice here, on tonight's practice, it may seem odd to you that I didn't ask you to solve them. I didn't. Okay. I just got you writing them out. Okay. So I want you to write these two on the screen. Okay. 8 more than a number is 12. So I want you to go ahead and write these two out. And then 21 is 3 times the number. Okay. So you write those two equations out real quick. Okay. So let's see how we did. All right. Now, all right. So here we got, oh, that person didn't put 12. You forgot to put the is 12. All right. Okay. So here we have 8 more than a number is 12. That's right. Then 21 is 3 times a number. That is also correct. Now, I'm going to translate it directly in the order it's in here. Okay. So if you got something that's similar but not exactly the same, that's fine. So I would start with the is, that's the is, equals 12. 8 more than means 8 plus a number. So if you put n plus 8 equals 12, is that also correct? Yes. So that's called commutative property, right? N plus 8 equals 12. Okay. So that's the same thing. 12 equals n plus 8. Also the same thing, right? All right. 21 is, so there's our equal sign, 3 times a number, 3x. Okay. So if you put x times 3 equals 21, is that correct? Yes. If you put 3x equals 21, also correct. Okay. So those are fine. Okay. Any questions on that one? So make sure you have a version of a right answer for both of those. Okay. So we have something that's like 8 plus n equals 12, and then something that is like 21 equals 3x. All right. I'm moving on in 5, 4, 3, 2, 1. Okay. All right. So we only got, I think, 2 more here. All right. Now for some different sort of word problems. Okay. So we have mice, cat. Let me double check what the next slide is because I think I have one for me to go through some of these and some one for you to go through. No, I want you to do these two. Okay. So Mike's cat lost 3 pounds. Okay. It now weighs 12 pounds. Write an equation to find its original weight. All right. So I want to kind of walk you through this. So it now weighs 12 pounds. So what that tells you is it now weighs means its weight is 12 pounds, right? So therefore, write what you think this right here means, okay? Write what you think it now weighs 12 pounds means. Just at least figure that part out. See if you can at least figure out what it now weighs 12 pounds means. Because I think this is kind of the key here. Okay, some of y'all are getting it. Yeah, that's exactly what I'm talking about right here. This is, okay, right here, you see it now weighs 12 pounds. That means it equals 12 pounds now. So to me, the key to getting to starting off one of these word problems is seeing what it equals. So I see that equals 12. So now the cat's weight equals 12. Okay, so if we're thinking about he lost some weight, that means that's a minus, right? So if it's a minus, well, is it 3 minus something or is it something minus 3? Well, it's something which we don't know minus 3. So what's the something that he weighed? Well, some of y'all wrote W. Perfect. Or you could just write a X. It doesn't matter. So it's his weight before minus 3 equals his weight now. All right. Now, some of y'all went ahead and wrote 15. And that's technically kind of cool, but right now I'm wanting you to write it in an algebraic way. So in other words, I want it to look like this one right here. X minus 3 equals 12. Or W minus 3 equals 12. Okay. So the answer is it's 15. Yeah. But right now, we're not solving. Okay. Because one of the biggest things I've noticed people struggle with is they get where they can solve equations, but they don't know what the equation is. So right now, I just want you to focus on, do you understand why this is X minus 3 equals 12? Okay. Any questions on that first? Okay. Second one, Jane and her dog together weigh 108 pounds. Okay. So they weigh that all together. So this means their weight together is 108 pounds. Does everybody see why that's the equal sign? Everybody see that the equal sign goes with the 108. Let me explain that again because I think some of you didn't get that. All right. Stay with me here. Okay. This is pretty important. So it says Jane and her dog together weigh 108. That means they add up to 108, right? So that refers to an addition situation. Something plus something equals 108. Okay. Now we have Jane weighs 89 pounds and D for the dog. So go ahead and finish that one. Okay. So if you got the all right. So somebody right here, y'all, that's not what I'm wanting here. I want this like the addition. So I don't want this. Okay. I don't want this either. Okay. It needs to be go back, look at mine. It equals 108. We got Jane is 89, the dog is D. Okay. Together it equals, they weigh together 108. Okay. So what we need here, some of y'all still got it wrong. Okay, is we need this, right? Or we need this. Okay. So 89 plus D equals 108, or D plus 89 equals 108. Okay. Or technically, you could put 108 equals D plus 89. But the way this is written here, it says addition equation. That means, you see, so if you put some subtraction one, you're wrong because that's not what it said. Okay, so it's 89 plus D equals 108, or you can reverse this. D plus 89. Okay, questions on that one? Okay, now this next one right here is what I would call a classic stupid math problem. Okay, Sai's father is 3 times as old as Sai. If Sai's father is 39 years old, how old is Sai? Okay, we're going to write and solve the equation, and C is Sai's age. Okay, so C for Sai, and then his father is 3 times as old as Sai. So what we're really working with here is just his father's age is 39. Okay, so basically it is 39. So we have, think about it like this: Sai is C. His father, right? So this is another way of looking at this, is 3C. Okay. But we also know his father is 39, right? So therefore, whatever 3C is has to equal 39. So he's 3 times as old as Psi. Psi is C. So 3C equals 39. Yeah, he's 13. That's not the point. The point is that you can get to right here. Okay. Any questions on how I got to there? So 3C equals 39. Okay. C being his age. Or like this one, C times 3 equals 39. That's good. All right. Not this one. So not that. Okay. So technically, this could work on this one because it doesn't say multiplication equation. I will tell you that it is this way right here because most test questions are going to have it written. The answer is going to be written like what I did right here. Okay. Am I grading right now as well? Yeah, Gina. When I look back at these, I'm going to see if everybody did what I told them to do. Okay. That's the reason that sometimes people like don't have 10 out of 10 points on there is they're not making it look the way it's supposed to. Okay. So 3C equals 39 somewhere on there. Okay. Questions? Okay. Give you about 10 seconds to finish that one up. And then we got one more slide. Okay. 5, 4, 30, 2, 11. All right. Here we go. Okay. So this one gives us 3 different situations. So this is kind of goofy, but you're supposed to decide which equation best represents the situation. So we have after Elena ran 5 miles on Friday, she had run a total of 20 miles for the week. She ran X miles before Friday. Okay, so what I would do here, all right, I would recommend you to not look down at the answers until you've attempted to write the equation. Okay, I think that's the best way to get better on these. So I wouldn't look at the equations until I tried to write all the answers. So I would try to write the answer to this one first before I even looked at these. Second one, Andre's school has 20 clubs, which is 5 times as many as his cousin's school. His cousin's school has X clubs. All right. And then Jada volunteers at the animal shelter. She divided, that's a pretty easy giveaway, 5 cups of food, cat food, equally to feed 20 cats. Okay. Then each cat received X cups of food. Okay. Now, that was tricky because there's no division equation on here. All right. So let's give it your best shot and then we'll go over it in about 1 minute. So try your best on those 3. Then we'll look over it. You need to give it a try before I do it. All right, so I'm gonna start giving you some hints here. A total of 20 miles for the week. That should equal 20. All right. Andre's school has 20 clubs. That equals 20. All right. This one's a little more confusing. I'm gonna have to talk through that one a little bit differently. All right, so let's see what we got here. Let's see, a few people are getting it. This to me, being able to do these is kind of the difference between like a meets and exceeds. Okay. If you can write it from these situations, that's probably what it's going to take to be exceeds. Maybe it's certainly, the easier ones, like one would be more of a meets. If you can do three, that's more of exceeds. Okay. All right. So after Elena ran 5 miles on Friday, she had run a total equals 20. She had run X miles before Friday. So she ran X before and, or plus, she ran 5 miles on Friday. So now she's run a total of 20. Okay. So that one's right here. Okay. 5 plus X equals 20. X plus 5 equals 20. Okay. So that one goes with number one. Andre's school has 20 clubs, which is 5 times as much as his cousin's school. So the cousin school has X, so Andre's school equals 20. So this is Andre's school over here. Andre's school also is 5 times as many as his cousin's school, which is X. 5 times his cousin's school is the same as 20. So that is this one. Okay. And then the final one, Jada volunteers at the animal shelter. She divided 5 cups of cat food equally to feed 20 cats. Okay. Each cat received X cups of food. All right. So to get to 5 cups of food here, all right, that's the total amount of food. That's going to be 20 cats times the amount of food they get. Okay. Or something like that. Now, if you're like, hold on a second, I thought it said divided. You're right. It did say divided. But if you think about it, dividing and multiplying are opposites or inverse operations. So here, when it says she divided it that way, another way of saying you divided it is multiplied by a fraction. So for example, the answer to this one's going to end up being 1/4. So watch this. Right? So 20 over 4 equals 20 divided by 4 equals 5. So that's how you get to that answer from there. Okay. But the point is that when it says she divided it up, then that, if you remember with multiplying fractions, we multiply by the reciprocal. So you're multiplied by it flip upside down. So if we said she divided it, right, into all those pieces, right, then if it fed 20 cats. So that's the way you would get to that one. So that one would be this one right here. Okay. All right. Now, so that kind of wraps up the situation here. So today's practice is working on words to equations. Tomorrow, more words to equations with the real world scenarios that we were doing at the end, and then a few different types of problems. And then Friday is the substituting in part that we did first. Okay. And then make sure you did your liftoff or Legends of Learning. And then, if you're struggling with things on the test, we can look at some skills, plan to retake. And then two, make sure that you are watching the videos going over the practice every day. That's really essential for you doing well in this class. All right. Otherwise, if you don't have any questions, I'll see you later.